Hello guys. Now let us see what is characteristic equation and what do we mean by similar matrices. So let us first begin with the characteristic equation. First example asks us to find the characteristic equation and eigenvalues of matrix A, and matrix A is given to us. We know what is characteristic matrix. Lambda times I minus A is known as characteristic matrix. Its determinant is called the characteristic polynomial, and when we equate such polynomial to 0, we get an equation. This equation is called as characteristic equation of matrix A. Once again, let us see. We take lambda times I minus A. When its determinant is equated to 0, this equation is known as characteristic equation. For this matrix, we are taking determinant of lambda I minus A equal to 0. Lambda appears on the principal diagonal. So we got lambda minus 5, lambda minus 4 along the diagonal, and the off diagonal entries, they are subtracted from 0, so they become 3 and 4. Solving this determinant, we got the equation as lambda square minus 9 lambda plus 20 minus the product 12 equal to 0. Ultimately we got this product to be plus 8, sum to be minus 9. We choose minus 8 and minus 1. So lambda is either 1 or 8. Both are the eigenvalues of matrix A. Let us move to another question. Question says find the characteristic equation and eigenvalues for this matrix. So again, characteristic equation means the determinant of lambda I minus A equal to 0. We are watching how to calculate it. Lambda I means identity matrix multiplied by lambda. From that we subtract A and its determinant equated to 0. Means we are getting this. After simplification, we got this to be lambda minus 2 bracket square minus 49 equal to 0. We can solve such equations in this fashion also. This 49 we have taken to the other side. We are getting both square numbers. We took the square root. So lambda minus 2 will be either plus 7 or minus 7. So value of lambda we got either 9 or minus 5. Now let us visit the concept of similar matrices. Two matrices A and B are said to be similar if there exists an invertible matrix P such that B is equal to P inverse AP. B is equal to P inverse AP. So I can write this as B equal to P was invertible matrix, so you can multiply by P inverse to A into P. So B is equal to P inverse AP. Matrices A and B are said to be similar matrices. Now this question is very important for us. Question says, show that two similar matrices have same characteristic equation and hence same eigenvalues. So suppose A and B are similar. A and B are similar means B can be written as P inverse AP, where P is some invertible matrix that we have written. Now we want to find out the characteristic matrix of B. So let us start. Lambda I minus B. This will be equal to identity matrix can be written as P inverse into P. And minus P inverse AP, the value of B we have just noted. Now this lambda being a scalar, it may be taken inside or out. It is scalar multiple of a matrix. So we have taken lambda in, and we know any matrix can be written as identity times the matrix. So identity can be inserted here. Now what you observe? This particular matrix is now expressible in the fashion P inverse times something into P. Here also we are having the same. And we know matrix multiplication distributes over addition, subtraction. Moreover, it is associative in nature. So, P inverse taken out, you can collect these inside. Same way P taken out. You can write this way. Simply keep in mind, matrix multiplication is not commutative. It is associative but not commutative. So we can write this as P inverse times this matrix into P. What you observe inside, this is the characteristic matrix of A. So what we observe, characteristic matrix of B can be written as P inverse times characteristic matrix of A into P, meaning the characteristic matrices are similar. So we can now go to the characteristic polynomial. So determinant of lambda I minus B will be determinant of this whole. But determinant of the product is product of the determinant. So we could write this as determinant of P inverse into determinant of lambda I minus A into determinant of P. One more thing we know. Determinant of the inverse of a matrix is reciprocal of its determinant. So determinant of P inverse I can write as 1 upon determinant of P. These two things kept as they are. Now these two cancel and we are just left with determinant of lambda I minus A. So what we saw is the characteristic polynomial of B is the same as characteristic polynomial of A. So they will have same characteristic equation and naturally they will have the same eigenvalues. So what we have shown, similar matrices have the same characteristic equation and hence have the same eigenvalues. Now the question arises, if two matrices have same eigenvalues, do you mean that they are similar? So this is not the case. So you can see these two matrices we have written. We know if a matrix is triangular matrix, the entries along the principal diagonal are the eigenvalues. At the same time, if the matrix is a diagonal matrix, still the diagonal entries are the eigenvalues. So you are watching matrix A, I have written 5703. Matrix B written as 5003. Both are having same eigenvalues 5 and 3. But you are watching that they are not similar matrices. So if two matrices are having same eigenvalues doesn't mean that they are similar. But similar matrices will always have same eigenvalues. So this is the remark that you must keep in mind. So keep solving. Thank you. Bye.